Okay. Now, suppose we got an FIR filter. Okay, I want to unfold it. So, we all know this should be replicated. Okay, there will be input buffer, output buffer. Hardware complexity will go up by 2 in general. We have seen that IIR filter example also there. Okay. Earlier. Okay. If earlier I had 1 adder, this becomes 2 adder, 1 multiplier, 2 multiplier. So, hardware goes up by 2. But now, using the polyphase decomposition will show that even if we unfold by j, we can play some tricks, DSP tricks, by which we can make sure hardware will not go up by 2, but maybe by 1.5. Okay, this is the beauty of that polyphase decomposition. So, we are choosing j to be 2. If that be, then we pick up this factor 2 from here. We go for Hz, Xz, Yz by m equal to the same factor 2. I pick up this 2 from here, which means Xz, we have already written the thing, it will be x0 z to the power m, that is z square, sorry, since m is 2, m minus 1 is 1, that means between every pair of samples I will have 1 0. So, x of 0 followed by a 0, then followed by x 1, then followed by 0, then followed by x 2, then followed by 0 likewise. So, x of 0 earlier was x 0, now also x 0, but x of 1 earlier was located at 1, now it will be located at 2 mth position. X of 2 earlier was at 2, now it will be at 2 mth position, 2 into 2 4, and so on and so forth. This is just from the general description earlier. This will be x z, this, and then z inverse 1 will stop at 1 because capital M minus 1 is 1 only, the other component. What are the components? What is x 0 n, which is equivalent to x 0 z? What is that? That is this sequence x 0 this is by x 0 n. Then we expand by 1, expand by 2, m equal to 2, that means between every pair of samples you insert m minus 1, that is 1 0. So, 1 0 will here, 1 0 here, 1 0 here. Okay. And similarly, x 1 n, other polyphase component, before expansion z transform is x 1 z, it will have x 1, x 3, again if you expand it, there will be 1 0 here, 1 0 here, 1 0 here, then you shift it to the right by 1, add with this with a 0 here, 0 here, you will get back x n. Okay. So, on this side before expansion is x 0 n, corresponding z transform is x capital X 0 z. If you insert zeros, it becomes a capital X 0 z square. Similarly, if you insert zeros, it becomes capital X 1 z square, then you shift it to the right by 1. So, z inverse this and then add, you get back original sequence as z transform. This just repetition of what we did earlier. This I am doing for capital X, I can do for y also. Similar thing, y 0 z square We all know the meaning of all these polyphase components. Now, what is yz? Yz is this, but yz also equal to xz into hz. If you replace xz by this, hz by this, multiply xz, then these two direct terms x0 z square, h0 z square plus z inverse 1, z inverse 1, z inverse 2, x1 z square, h1 z square. This is one expression plus the cross terms, z inverse you take common, capital x0 z square, h1 z square. Now, you equate the two, this yz with this yz. You see, here in the first quantity under bracket, everything is a function of z square, z square, z square, this is also z square to the power minus 1, z square, z square, all are function of z square. Y0 also here function of z square. So, this actually expression is y0 z square, this entire expression. And then z inverse common, z inverse common, after that y1 function of z square. So, here again this one you see function of purely z square, z square, z square, z square, z square. So, this is your y1 z square, all right. So, in the next page we can write cross terms h0 x1, h1 x0. Outside, I mean you put it in a bracket multiplied by z inverse. So, z inverse times this plus this, that is your yz. Okay. So, we will generate instead of z square, we will take y0 z and y1 z. We will first generate y0 z, y1 z. From z to z square means corresponding sequence you have to expand by a factor 2. So, z will become z to the power m, that is z2. Expanding by 2 means between every pair of samples m minus 1 zeros, that is 1 0. Okay. So, initially we will have y0 z. Okay. We will have y0 z will generate, which is nothing but h0 z x0 z plus z inverse 1 h1 z x1 z, and y1 z is your okay, these two. Ordinarily, how will I generate x 0 z corresponding sequence that polyphase component x 0 n? Suppose it is available. How available we will easily see. So, that is in z domain is x 0 z, that should go to h 0 z, okay. Similarly, here x 1 h 0, or x 0, if I take the same x 0, just a minute. I have suppose the other component. Which is polyphase factor 1 of order 1. Okay. Polyphase component 0th order, polyphase component first order. X 1 n means in z domain capital X 1 z. Okay, not expanded, so z remains z, not z square. So, we will have x 1 z multiplied by h 1 z. So, there will be h 1 z filter. And then it has to be output is to be multiplied by a delay and then added with this output. This will be your y 0 n, and then x 1 h 1, this is done. Y 1, how to operate one? X 0 will be through h 1 z, so it will be again h 1 z, same h 1 z repeated again. So, x 0 z h 1 z, okay, x 0 h 1, x 0 h 1 and h 1 and x 1 h 0, x 1. So, there will be h 0 once again. These two will have to be added. This is y 1 n. How to get back y n? Now, I know in z domain y z means from y 0 z, that is here, I have to make it y 0 z square, okay, plus z inverse y 1 z square. That means I have to expand this by 2, so that output is y 0 z square. I have to expand this by 2, so that output is y 1 z square, then shift it by or delayed by z 1 delay, that is z inverse, then add, that is this, with a delay. So, y 0 z square here, y 1 z square delay, and then you add this is y n, right. Now, let us look at the structure. Suppose H z is an FIR filter, say it has got 100 coefficients. Then H 0 z will be what? It will take H of 0, H of 2, okay. H 0, then polyphase factor, right. H 0 it will take H 4 dot 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 with origin here, and the other filter will be H 1 will be H 1, H 3, H 5 dot 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 with origin here. So, half of the coefficient will be here, it will be an FIR filter of how many terms then? 50, if total is 100 terms. Here also 50. So, I will have in each filtering how many multiplications? 50 multiplications. H 0 into x n, H 0 into x n plus H 2 into, I mean H 0 into x 0 n plus H 2 into x 0 n minus 1 plus H 4 into x 0 n minus 2 and dot 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 dot. So, there will be 100 terms. So, per convolution output, there will be 100 multiplications, sorry 50 multiplications here. So, 50, similarly 50, similarly 50, similarly 50. So, I have same for additions. So, 50, 50, 100, 50, 50, 100. So, it becomes 200. So, if I have not done any of these, I was given a filter H z with 100 coefficients. If I simply unfold it by making it parallel, 100 here, it remains 200. So, by this I am not getting anything here, 50, 50, 50, 50. So, total is 200, here also 200, 100 here, 100 here. I am just making parallel versions of this filter, buffer and all that. Here there is no gain, but I will show how to get gain, how to obtain gain. That will be very interesting, but before that certain basic things you see. What is x 0 n? This sequence is we know x 0 x dot dot dot. What is this? Maybe put an origin here. What is this? X 1 origin here, x 3, x 5 dot dot dot. Now, my input is x n. How will I obtain all this? One thing is in DSP you download it, decimate it by a factor 2 and all that, and similarly you can generate this, but actually you do not do that. If I have the same buffer which I used in unfolding x n and it is t by 2 now, t is the sampling period, clock period of the system, t by 2 shorter period, faster rate of the input. Okay. So, 1 t by 2 x of 0 comes, next t by 2 x of 0 here, okay, x of 0 here, x of 1 here, and then the switches close. X 0 moves out, x 1 moves out, then switches open. Next time in the first t by 2, x 2 comes here, then x 2 moves here, x 3 comes here, x 2, x 3 again they move in. So, x 0, x 1, next time x 2, x 3, next time x 4, x 5. So, by the simple switching arrangement, switching and buffering arrangement, we get these sequences here. So, no need to have decimator and all other things. Similarly, here as such I know if you expand between every pair of samples we will get 1 zeros, similarly 1 0, then shift by 1, then you add, the sequence will build up. Okay. But I do not need all these things, because what I will do is simply what we do in unfolding. So, in 1 t by 2, this y 0 0, okay. What is y 0 0? Y 0 0 is y 0. What is y 0 1? Y 1 0. y0 is y1, isn't it? y00 is nothing but y0. What is y10? It is y1. So, in one clock y0, y1 comes and they go out. So, first y0 followed by y1. Next clock y01, which is y2, then y11, which is y3. So, y2, y3, they move out. So, you get the sequence back y0, y1, y2, y3 like that. Okay, you do not need to have delay, I mean all this decimator or expander and all those things. Okay. This is very interesting. Now, here I did not have any gain, but I can have some gain. So, let me erase this first. Now, before I get into this thing, I will tell you something very interesting which is practiced today. Suppose you got two complex numbers a plus jb, c plus jd, and you want to multiply them in hardware. Now, there is nothing called j is just for reference. You have a and b one pair, c and d one pair. You treat this as real part, imaginary part, this as real part, this as imaginary part. So, your product will be, if you want to multiply the two, AC minus BD, this is your real part, and AD plus BC, this is your imaginary part. So, AC minus BD plus J times this is what we do. How many multiplier? A into C 1, B into D 1, A into D 1, B into C 1. 4 multipliers and 2 addition or subtraction. Subtraction is another form of addition. So, 2 addition. So, out of 4 multiplier I can bring it down to 3 at the cost of some extra addition, but additions do not really create any problem, they hardly require any hardware, multipliers do. The way it is done is this: you evaluate this AC minus BD and then calculate this A plus B, no J here, C plus D. So, A plus B one extra addition, one C plus D one addition, one multiplication. So, here I have got AD one multiplier, BC one multiplier. So, 2 gone, here third, then minus this fellow I bring back here, which is already calculated, that is AD minus BC, no need to calculate them, this is already calculated here. So, if you subtract out AD and BC from this result, AC sorry, there was a mistake. You calculate this real part, then A plus B, C plus D, from that you subtract AC and BD. See, you are calculating this, to obtain AC minus BD, you have to do this multiplication AC, you have to do this multiplication BD. So, those results are available. So, now to obtain the other result, that is AD plus BC, the imaginary part, this is the real part. Real part you calculated by finding out the product AC, finding out the product BD and subtracting. Now, what you are doing? You are doing A plus B one addition, C plus D one addition, multiplying. From this product, subtract out AC, which is calculated, subtract out BD. So, only the diagonal cross terms remain BC and AD. Okay. So, you have got 1, 1, 1, 1, 4 additions and only 3 multiplications, 1 multiplication here, 1 here, 1 here. So, by having 2 extra addition, you can bring down the number of multiplications by 1, and this is how it is done in practice today. Same philosophy I will bring in here. I will calculate this as it is y 0 z as before and y 1 z I will calculate as, forget about the z inverse, it is like a b okay, c d. So, I will have it is like a d plus b c like that, you know. So, I will have h 0 z plus h 1 z times x 0 z this. So, already I have minus, I will take this product minus I will take this product. So, the two cross terms h 1 x 0 here and h 0 x 1 they will remain. Okay. This is already evaluated, no need to re-evaluate. So, here so this philosophy will bring down my hardware cost easily, which we will see now. Okay. So, as before I have a buffer we have already seen this gives rise to x 0 n polyphase factor of order 0 polyphase, this we have already seen, right. It is coming at t by 2, t is the clock period of the system. I need to have h 0 z x 0 z. So, let it go to h 0. I need to have h 1 x 1. So, let it go to h 1. As before y 0 z no change. This by y 0 n, simple na, z inverse x 1 h 1 x 1 h 1 and h 0 x 0 h 0 x 0, that is y 0 n. Other one is what? First, another filter whose transfer function is neither h 0 or h 1, but h 0 plus h 1. And its input is neither x 0 nor x 1, but their addition. So, these two fellows will get added, these are the extra additions they are coming in, multiplied. From this I have to subtract out h 0 x 0, h 0 x 0 is here. So, I subtract out, from that further I have to subtract out h 1 x 1, h 1 x 1 is coming here. This is my y 1 n, and then as before I will give it to a buffer. I will generate y n, absolutely fine. Now, here you see how much is the hardware increase. This is h 0 n, h 0 z. See, originally I had 100 coefficients, this will have roughly half, 50. H 1 half 50. How about this? Interestingly, this also will have 50, because H 0 z and H 1 z means what? H 0 z is H 0 followed by H 2 followed by H 4 dot dot dot, and H 1 with origin here, and this is H 1 with origin here, H 3, H, 5 and dot dot dot, and you are adding. So, 50 here, 50 here, but added also will have a, if you add the two sequences, resulting sequence also will be having the same length 50. So, this will be a filter with 50 coefficients only. So, now 50, 50, 50, 150. Earlier it was 200. Okay. This is the beauty of it, just by using these tricks. This is a very simple one. In the next class, I will consider j equal to 3, and obviously I have to consider the polyphase factor of polyphase decomposition of order 3, which is more complicated and cumbersome, but then we will just give the results. Okay. So, you get a feel that, I mean, in the case of FIR filter, hardware increase can be brought down. Okay. Why not IIR filter? IIR filter, even if you take the H0z, original Hz, original Hn in time domain had infinite number of terms, because IIR, if you decimate by 2, if you take this 0th order polyphase component, even that also will be infinite in length, H1 also will be infinite in length, and their summation also infinite in length. So, IIR, IIR, infinity plus infinity plus infinity. So, that really does not change, but in the case of FIR, originally 100 means say 50 here, 50 here and another 50 here. So, 150. That is all for today. See you next time. Thank you.